In the last video, we looked at the tan function, and we looked at an introduction into that function. We saw that tan theta was the same thing as sine theta over cos theta, and because of that, we know that at 0, 180, and 360 degrees, tan theta is 0 because at those angles, sine theta is 0. And the most important thing we saw was that at 90 and 270 degrees, because at these two angles cosine theta is 0, we know that dividing by 0 is undefined, and because of that, at these two angles, we are going to have two vertical asymptotes in the tan function. And in this lesson, we're going to take a closer look at all of these special angles for the tan function. And we're going to plot the function and see that the tan function has a very different shape to the sine and cosine functions. So let's take a closer look at the tan function now. So I'm going to take a second to actually write out a few more angles for tan theta so that we can plot these angles and see what we get in addition to our information about these two asymptotes. One thing that I want to mention is we saw with the sine and cosine graphs that we had quite a few special angles for which our sine and cosine values were either 0, 1, or -1. We're going to have the same trend with tan theta where we're going to have values of either 0, 1, or -1, but whereas with sine and cosine, we found those values at 90-degree increments. If you can recall, we looked at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So that's going up in 90-degree increments, and that's where we really saw our important values for sine and cosine. With tan theta, we're going to be going up in 45-degree increments, and at these 45-degree increments is where we see the tan theta graph taking on those important special angle values. So we need to go up in 45-degree increments with tan theta, which was different to the 90-degree increments that we used with sine and cosine. So let's start out with tan of 0 degrees. Tan of 0 degrees is going to be 0. And again, you can validate any of these that I'm going to be writing down by just plugging this into your calculator. If you plug in tan of 0 and make sure your calculator is in degrees mode, it's going to give you a value of 0. So tan of 0 degrees is 0. And that makes sense because we know that sine theta is 0 at 0 degrees, so that makes sense. Then at 45 degrees, because again, we're going up in 45-degree increments with the tan graph. At tan of 45, is going to give us a value of 1. Tan of 90 degrees is going to be undefined. This is where cosine is 0, and so we're going to be dividing by 0, which is not allowed. So this is going to be your first asymptote. Then at tan of 135 degrees, tan of 135 degrees is -1. Tan of 180 degrees is equal to 0. Tan of 225 degrees is equal to 1. Tan of 270 degrees is undefined again. We are going to be dividing by 0, which is not allowed, and we're going to have another asymptote at 270 degrees. Then we have tan of 315. That is going to be equal to -1. And tan of 360, which is 0. So we can see again, like our sine and cosine graphs, that we're going to be fluctuating between values of 0, 1, and -1. And the main difference is we're going to have these two asymptotes in the tan graph when we are looking at 0 to 360 degrees. And we're going to see that the tan graph is very, very different looking to the sine and cosine graphs. So I'm just going to make this a little bit smaller so we have some more space to actually plot in our graph. And I'm going to draw out a plane over here. And one thing that I want to make a note of is when I've been drawing planes like this for all of our trigonometry videos to draw the sine graph, which was like this, and the cosine graph, which was like this. And I just want to remind you that when I'm drawing a plane like this is the same thing as the first and fourth quadrants of our Cartesian plane. So this is simply just looking at the two quadrants of our Cartesian plane. I could just as easily draw a plane that looks like this and that would be the Cartesian plane that we've been used to, where we have our positive x values, positive y values, negative x values, and negative y values. But just for simplicity, when we've been dealing with our trigonometric graphs, I've only been showing this side of the plane. So it's the same thing as just showing this side of the plane. And you should just keep in mind that in our previous videos, when I've dealt with the sine and cosine graphs, and in this video when I deal with the tan graph, I'm going to be focusing on these two quadrants of the plane, but there is going to be a negative side to these x values. So we can have our same angles from 0 to 360 degrees, but from 0 to negative 360 degrees. So we can have the exact same thing on this side. So the sine and cosine graphs are going to look exactly the same on this side between 0 and negative 360 degrees. So just out of simplicity, I've only included these two quadrants. So I just want to make a note of that so nobody gets confused with the differences between the plane that I draw in this fashion and the other Cartesian planes in other videos that have had all four quadrants included in them. So I just think it's important to make a note of that. So here we have our Cartesian plane, the two quadrants of the Cartesian plane. And I have put in the same angles that we dealt with sine and cosine, which were the 90-degree increments, 90, 180, 270, and 360. But I've also included in here the 45-degree angles that are in between all of these. And that's because we're going to see that at those 45-degree increments, that's where we actually see the tan graph taking on its characteristic values. So remember, for the sine and cosine graphs, you only need to put in your 90, 180, 270, and 360. But for the tan graph, we're going to need these 45-degree increments in between. And I'm not going to write down the actual numbers in there because it'll make this look a bit messy, but just for your information, this is 45, then this is going to be 135, then this will be 225 and 315. So this is just the 45-degree increments in between these other values. So let's start to put these in. So we know that tan of 0 degrees over here is 0. So we're going to have 0 over here. Then at 45 degrees, it's going to have a value of 1. And actually, before I even do this, I should have put in the asymptotes. That's the first thing I should have done. So I'm going to quickly do that now. Always remember that the first thing that you want to do when you're dealing with the tan graph is put in your two asymptotes. So we have two asymptotes from 0 to 360 degrees here. The first one is at 90 degrees and the second one is at 270 degrees. And already we can tell that because this is the x-axis and we have these asymptotes for the entire 90-degree point on the x-axis, these are going to be vertical asymptotes. And I'm going to put them in here in red. And these are going to be lines that our function is going to approach but never touch or cross. So now that we've got our asymptotes in, we can keep plotting our values here. So we were at 45 degrees, which is a value of 1. At 90 degrees, we have our asymptote. At 135, we're going to have a value of -1. At 180, we're at a value of 0. At 225 degrees, we're going to have a value of 1. We have our asymptote again at 270. At 315, we're going to have a value of -1. That's going to be here. And at 360, we're going to be at 0 again. So what it's looking like is that we have these 3 points that look like it's going to be a diagonal line. But that's actually not going to be the shape of the tan graph. I'm going to draw in what the actual shape looks like, and that's just going to be something to make a note of because it does have a quite characteristic shape. So what the tan graph is actually going to look like is this. So this is what the tan graph is going to look like. It's going to have this squiggly shape where it is going to have an inflection over here. And this is the characteristic shape of the tan graph. It's going to have two asymptotes around which we're going to have this characteristic squiggly type shape. So on this side, this line is going to keep going on and on and on indefinitely to infinity. and it's going to get closer and closer to this asymptote, but it's never going to reach or touch it. And down here, it's going to do the same thing, but in the other direction. So this is going to keep going down and down and down until infinity, and it's going to get closer and closer to this asymptote line, but never touch it. And we're going to see this same shape, this exact shape like this, is going to repeat over and over and over every 180 degrees in between those two asymptotes. So here, between 90 and 270, this is 180 degrees between 90 and 270 degrees. And here we're seeing an entire period of the tan graph. Over here, what we're seeing between 270 and 360 is half of a period of the tan graph. And here, from 0 to 90, we're also seeing half of a tan graph. We're just seeing the other half of what this would be. So this shape that's in between these two asymptotes is going to repeat over and over and over in both directions, and the period of the tan graph is going to be 180 degrees. So the entire tan graph, which is this shape here, is going to be complete in 180 degrees. And that is something very different to what we saw with sine and cosine. You can recall that with the sine and cosine graphs, they had one period in 360 degrees. They had their characteristic shape, which started out at 0, ended at 360, and then that shape was repeated over and over and over every 360 degrees. But with tan, it's different. Our period for the tan graph is going to be 180 degrees. So it's going to complete its shape in 180 degrees, and then every 180 degrees, that shape is going to repeat over and over again. The difference also is that when we're starting at 0 here, we're only going to be seeing half of that tan period. So we're seeing the second half of this tan period. And on this side of the Cartesian plane, when we're going into our negative degrees, we're going to see it complete its shape on this side. So on this side, it's going to look like that. And we're going to have another asymptote in red over here that this line is going to constantly approach and get closer to. So this shape is going to repeat over and over. It's just because I haven't shown this negative side that we're not seeing that this is going to have another half that goes down here into our negative degrees. And this asymptote here is going to be at negative 90 degrees. We're going to have another asymptote at negative 270 degrees, so somewhere here. And then in between those, we're going to have another one of our tan curves. So that's good just to make a point of that this is going to complete its shape down here. It's just going to be in the negative degrees. But the most important thing to note is that this is the characteristic shape of the tan graph, and it's going to repeat itself. It's going to be this shape in between two asymptotes. And that is just the point that I wanted to make in this video. It's important that we understand what the tan graph looks like and that we can see how it's vastly different from the sine and cosine graphs. We can see that this is a very different looking graph than the graphs that we dealt with when we were looking at sine and cosine. So if there's a takeaway from this video, it's going to be that our tan graph is going to have two asymptotes. It's going to have a point in the middle where it is going to kind of change its shape. On one side of the asymptote, we're going to be approaching the asymptote and going down to infinity, and the same is going to happen on the top side, and in between we have this squiggly shape. It kind of looks like a backwards S type of shape. So when we actually have those 3 points, it does look like this graph could be just joined by a straight line, but that is not what the tan graph looks like. We're going to have this kind of characteristic backwards S shape, and that is going to be the characteristic shape of the tan graph every time. And I haven't made a point of it here, but I'm just going to make a point of it that tan theta has a period of 180 degrees, not 360 like we saw with sine and cosine. So the tan theta graph has a period of 180 degrees, meaning the graph is going to complete an entire wavelength in 180 degrees. And this is one wavelength of the tan graph. And in the next video, we're going to look at the general form for a tan function, which is f of theta is equal to a tan theta plus q, and we're going to see what the effects of a are on the appearance of this graph and what the effects of q are on the appearance of this graph.